Hello and welcome everyone to another webinar in the Connection Wednesday series. However, this one will be a little bit special, first because of the topic, connection design automation, and also because of the speakers. So let's perhaps start with the speaker introduction. Nathan Luke, joining in, our BIM specialist. Nathan, this is your first appearance with the StatiCa on a webinar, so if you could introduce yourself.
Yeah, thanks, Wojciech. It's good to be here. So I'm Nathan. 7 years experience as a structural engineer with Oricon Australia and Grasshopper in the UK, and then worked for 3 years as a BIM and I guess engineering automation developer and support at Geometry Gym. Been at StatiCa for six months now. And as a BIM specialist, and very happy to be here and looking forward to the presentation today.
Thank you for that. Very happy to have you here. We also have a special guest with us today, Ryan Ajus. Ryan, the same goes for you. Some of the members of the audience might already know you, but for those who don't, how are you doing? What do you do?
Yes, thank you, Nathan and Wojciech, for having me here. My name is Ryan Ajus. I'm an automation specialist working at Bouw & Staal. This is a branch organization representing the Dutch steel construction industry. And there I design applications, also Karamba IDEA, which we do together with Nathan and Wojciech. And a large part is also promoting computational design within the Dutch construction industry. Aside from that, for the rest of the week, I work at ABT, which is a multidisciplinary engineering firm, and there I work as a structural engineer. So I can actually put into practice what I preach at the branch organization at Bouw & Staal.
That is right. Thank you so much for joining us today. Ryan will tell us a bit more about his Karamba IDEA plugin later on in the webinar. And that leaves me, Wojciech Chalupa. I'm a product owner with StatiCa. My background is in structural steel design, and I have the pleasure of taking you through the webinar today. So as usual, you are muted as an audience. So if you want to interact with us, pose us questions, you can do so. You should see a panel, control panel on your screen, and in the questions tab, you can ask us questions. We will answer them throughout the webinar. The more extensive ones, the more difficult ones, the more tricky ones, we will answer after the webinar and send you the responses later. The webinar will be recorded. So if you need to jump out, perhaps, don't worry. You will find the recording on our YouTube channel afterwards. So what we'd like to do, if that's okay with you, we would like to get to know you a bit better as an audience. So we'll do our first poll. Nathan, would you be so kind and introduce the first poll?
Definitely. So we'd just like to know what's your main area of interest. So what's the main thing you're working day to day? Is it global structural analysis? Do you work primarily in computational engineering? Are you more on the detailing and fabrication side, research or academia, or interoperability and BIM? Are you doing that sort of as your day-to-day job?
Awesome. I already see that more than 50% of you have already voted, so I will keep the voting on for 20 seconds or so that everyone can get a chance to get a vote in. Let's give it another 10 seconds. Mostly global structural analysts, engineers, which is expected, but I will share the poll results with you right now. And you can see that indeed 60% global structural analysis, but we also have computational engineers with us. We also have fabricators and researchers too. which is very good. A very diverse audience, I would say, but don't you worry. I promise that no matter your main area of expertise, you will learn something interesting today. So thank you for that. Thank you for answering the first poll. And when I say you will learn something interesting today, what exactly can you look forward to? So first, we will talk about connection design automation and what that means in the context of StatiCa and its applications. Then I will introduce the open model and our plugin, and also introduce you to the concepts of developer mode, templates, and parameters. Then it will be Nathan's turn, and he will do an example using these concepts to perform a Weld optimization algorithm using visual programming. And also Ryan will tell us a bit about Grasshopper, his plugin. Following that, another example from Nathan using Grasshopper and visual programming to do more than just optimization, but generation of connections, etc. And at the end, if we still have a bit of time left, we might do a little Q&A session. So Adam will be sorting through your questions, and we might answer some of the more interesting ones live. So this is the agenda, and without further ado, let's jump right in. So what do we mean when we say connection design automation? It is a process that helps you get from your global structural model to a connection design that you are happy with in the least amount of time and with the least amount of mechanical, boring, repetitive work. You don't want to be retyping values and pushing buttons. You want to focus on the creative aspect of connection design. And we've identified a couple of intermediate steps to get to that goal. First, you have your global structural model with your directions, members, internal forces. And that needs to be translated into something StatiCa can also understand. So once you are in StatiCa, you can do your first design, and most likely it will not be the optimal one right away. So you need to iterate and optimize, add stiffness, change the plate thicknesses, bolt dimensions, etc. And then you arrive at your final design. And finally, you are left with a well-designed connection. The understanding part is facilitated by the IOM, Idea Open Model, and I will introduce IOM in a minute. This second part is again facilitated by our Idea plugin that is able to interact with StatiCa. And I will also talk about Idea plugin before Nathan shows it in a demo. So what is IOM exactly? Idea Open Model is an open source C# framework, and it can describe structures. And it can describe them in a way that StatiCa can understand them. So here you see a screenshot of our GitHub page, and you are more than welcome there if you find any of this interesting. We will be sharing the links to it on the landing page of the webinar, where you will also find the recording. So at the end of the webinar, I will make sure that you know where to look for all those interesting and important links. And let's look at the IOM. Let's look at the parts that compose the IOM. So in the IOM, in the open model, you have your nodes and your geometry, firstly. So directions of your members, their local coordinate systems, etc. Then you also have cross sections and materials that are used in the model. Also, there are internal forces that we use as actions to load our connection models. And finally, the IOM is also capable of storing the connection parts. If you are a user of StatiCa connection, you know that you apply and construct the connection using manufacturing operations. What is stored in the IOM are not the manufacturing operations themselves. These are just the basic parts, exploded operations into very easy to describe and very easy to communicate parts, such as plates, welds, bolts, and cuts. And that's basically it. This is what is stored in the IOM, and it can be represented as a human readable XML file. You can see a part of it on the left here. So you can see the project data. You can see a couple of points in 3D. Then you would have your members, materials, etc. So just to reiterate, when thinking of IOM, Idea Open Model, you can imagine an XML file that describes a steel structure with internal forces as well. Now, I just want to briefly mention templates. Templates can be used to transfer manufacturing operations, and now I am talking about the ones that you use in a connection app, so end plates, wideners, and you can transfer them between IDEA connection files. So what templates do, they store information about these manufacturing operations and their sequence. So basically store information about the connection design. So I can take a naked connection on the left, and by applying a template on top of it, I can receive a designed connection on the right. Parameters are another very useful tool, mostly for optimizing. They are available in the developer tab, which by default is not visible in the connection app, and you can learn about accessing it on our GitHub wiki. Again, the link will be shared with you after the webinar or on the webinar landing page on our website. What parameters allow me to do is modify the model I have by linking them to properties of a manufacturing operation. So what I've done here is I've created two parameters and I've linked them to the thickness of a stiffener and to welds of that stiffener. So now I can use code, or I can do it manually, of course, but we will be talking about automation. So I will use code to change these parameters around, and that will also change the underlying model. Do not worry if this is too much to take in. If you are just starting with Idea StatiCa or starting with automation, Nathan will show everything in the upcoming example. So that should all become quite clear. But before the example, the last and perhaps the most important part, the Idea StatiCa plugin. This is basically our API, a way to interact with the software using code. And you can use it to take, for example, the open model file and create and save an IdeaCon project. This is a project that you know if you work with Idea StatiCa. It's a typical project file containing a connection design. So you can create it using the plugin, and you can also use the plugin to then interact with it, apply templates to it, update your loads, set parameters, and of course run analysis and read the results of the analysis. Idea StatiCa plugin can be called using Python or any other language, and it can be integrated into your visual programming tools such as Grasshopper, Dynamo, Jupyter, Excel even. So while we will be using C# today to demonstrate the workflows, don't worry. If you've never seen Visual Studio before, you don't actually need to know the ins and outs of everything, how to write the code in order to take advantage of all of this. You can perhaps use a tool developed by somebody like Ryan to make use of this. So hopefully I managed to explain the difference between the IOM and the API. While the IOM defines the underlying model, the API allows you to interact with it. You don't actually have to have a license of Idea StatiCa to generate IOM, but you need it in order to use the calls in the API. That requires you to have a license and to have Idea StatiCa installed. You can also take advantage of our NuGet packages that are available, the Open Model NuGet for IOM and the plugin NuGet for the API. So now coming back to my first slide, showing the steps you might take manually when designing a connection. We can take another look at it, but now using automation. So you would use IOM to translate your structure into something StatiCa can understand, and then use API to generate a connection model on top of it. In order to get the first design in, you would apply a template. And in order to get to your optimal design, you would get and set parameters until you arrive at a satisfactory calculation result. And then when the connection design is basically done, you might want to export the results, for example. So this would be it in a nutshell. And as I promised, enough talking. Let's see all of this in action. So I will ask Nathan to do the Weld optimization example now for you.
Thanks, Wojciech. So I just want to go through an example today and how we can demonstrate those workflows that we've been talking about. And I'm just going to start with the example that I have open. And this is sort of a, I guess, a tube connection that we may have designed somewhere else on a project or on another project. And we might want to reuse this or the operations that we defined for this particular joint. But we also might want to, I guess, be able to update weld thicknesses and stuff like that if you know the new connection that we want to use those operations on has different loading or slightly different topology or section sizes like that. So under the developer tab, what we can start to do is start to generate parameters, and we can assign parameters to operation properties in the model. So you can see here on the left, I've created 3 different parameters. I've got a cold weld parameter and 2 chord weld parameters. And these are number parameters, and currently, I'm sorry, but these are required to be in metric units, just because I guess the base units of the program are in metric. And also this value does relate to the throat thickness. We will look to improve this in future versions. So what I can do is assign this parameter to a model property or parameters that are in the model. And so you can see here cut 1, and you can see here that I can assign these to a thickness, and in this case it relates to the weld thickness. So I can do that for these for cut 1, cut 2, and cut 3. So if I just demonstrate updating one of these values, I can change that value and then click set to model, and you can see that the weld is updated. So what I want to be able to do is export this as a template so I can start to optimize these welds for another topology or another connection design. So under the developer tab, there's a save as template as well, and I can click that to save it as a template, and I'm just going to save it to one that I created earlier. So now I just want to introduce a Visual Studio example that I'm going to use to demonstrate how we can basically create that StatiCa file from the IOM, apply a template, and then we're going to look at some how we can optimize the welds in that connection as well. So just briefly on this connection, on this project example, if I just go to the properties, it's a .NET framework and it's a console application. So just a simple console application. If I have a look at the dependencies, you'll see that I have my StatiCa plugin installed, and these are installed through NuGet packages. So that's how you can access our API in through Visual Studio. Just before I get back to the example itself, I'm just going to quickly show how you can look in the object browser to understand what is available within this the plugin or API. The two main items that we're going to be looking at today are the con hidden client factory and the connection hidden check client. So if I click on the check client, I can see all the available methods that are available within the plugin API that are going to allow us to interact with StatiCa connection in the headless mode. So I have the ability to open projects, get information such as bolt assemblies, or also set things within the project, and also apply templates. So let's have a look at the example. And with all console or C# console projects, they'll typically have a class named program, and all the code will be run under this main method. So we're just going to keep it simple and run all the code within this method. There is another file optimization parameter in this project, which I'll demonstrate a little bit further down. So the first thing that we need to do is create the calculation factory, and the factory takes the program path or the path that where StatiCa is installed. For this example, we're going to use StatiCa 22, and I definitely recommend downloading the latest version to get all the features that are going to be shown here today. Once we have that calculation factory, we can call the create method, and that's going to give us a client that we can use to start to interact with StatiCa. I've got all the folders, the files that I'm going to work with in a folder path here, and if I just click on that folder again, I can see that I've got my IOM model XML and also my model results as well, and the template file that we're going to use for this example. So the first thing that I'm going to do is create that idea connection project from the IOM information that we have. So it's going to take my IOM model path, my results path, and also that idea connection path that we want to generate. Once we've done that, we're going to apply the template. And what we need to do is we need to reopen that connection project that we've created. The create connection project from IOM doesn't leave the project open. It's good to know that. So before we apply the template, we just need to get the first project, or the first connection in the project. Obviously, StatiCa allows to have multiple connections within one project file. And then we can apply that template using the client.apply method. We need to provide the connection identifier, or the identifier of the connection we want to apply the template to, the template path which we specified before, and also some template settings. You can see here I've just assigned the default template settings. You can have a play around with this if you like. We're also going to save as the project with a new file path. We could just save it if we wanted to, but I want to check the difference between those two files. And then lastly, we're going to close the project again. So I'm just going to hit run on this example. And what it's doing is it's going to create the connection with the StatiCa, and then it's going to create that connection file. And I'm going to get so I've got a prompt to press a key to apply that template now, and now the template's been applied. So let's take a look at those files in the folder now, and I'll just open both of those. I'll just go to the first one. You can see that I just have the base geometry, unbalanced forces, which is great. And then if I go to the second one with the template applied, you can see that the operations have been applied now. And you can also see that the parameters have also been applied with this file. So we're going to use the API to start to optimize these welds based on the parameters. So let's jump back to the example now. And we're going to go down to this region 3, the weld optimization. So what we're going to do here now is reopen that project with the template applied. And then the main thing we're going to do here is use the client to get the parameters. Now we're going to get the parameters, the JSON string, and we can deserialize that into parameters we can use in C#. What I've created here is a weld thickness optimization parameter. And if I click into that, I've given it a couple of properties. And I've given it an initial value of 0.03. And again, these are in metric just to follow along. Increment value, and this is going to basically increment each weld parameter if it isn't satisfactory in the design through each iteration. I've also given it a max value if I don't want the weld to, I guess, increase in value. And what this optimization parameter is going to do is update that parameter value with each iteration. A couple other options is the save iteration. So whether I want to save iteration after each iteration through the loop, and then also a maximum iteration. So the optimization here is basically just a for loop, and at the start of every loop, it's going to run through those parameters and set the value. Then the parameters will be updated and applied in the connection, and then it's going to calculate the results of that connection, and then it's going to go back and check to see whether that parameter is optimized or not. If it's not, it'll update it to the next iteration and so on until all the welds have been optimized. Okay, I can jump back to the console now where I can start the iteration. And you can see after the first iteration, it's set all the welds to 0.16 of an inch. And you can see after the first iteration, none of the welds are satisfactory, so they've been bumped up to 1/5 of an inch. And still, after the second iteration, the welds are still unsatisfactory, so they've been bumped up again. And again with the third iteration. And after the fourth iteration, you can see that the column weld has now been optimized. So the value of that will stay. And then the other two are still not satisfactory, so have been bumped up. And finally, after the sixth iteration, all welds have been optimized. So we can go to the folder now and have a look. You can see that we've got our 6 iterations. So I can click on that last iteration to view. And you can see that the welds have been optimized. Now we can calculate that. And you can see that everything's within a good limit. So that's the end of this example. I hope you've enjoyed it, and I hope you can take it and enhance it or improve it to something that will benefit you guys in the future. So I'll pass back to Wojciech now to continue.
All right, thanks Nathan for a very interesting example indeed. This example will also be available for you to download after the webinar on the landing page. I thought I just might want to mention that. So hopefully you've enjoyed the example as well. And now I would like to ask you one more thing, since we've now seen the C# code. So we are wondering, what is your computational experience? So let me just launch the poll, and please select one of the options. Do you use Excel spreadsheet in your daily practice, macros, VBA scripts, or are you more of a visual programming engineer? Do you perhaps have basic knowledge of a programming language such as Python or C#? Or are you a full-time software engineer? Again, I will let the poll run for additional 10 to 20 seconds. Most of the votes have already come in. And when I share the results with you, you'll see that we have a significant number of people with some computational experience, visual programming or basic knowledge of a programming language. So I am stopping the voting now, and we can quickly check the results. So Nathan, what do you think about the results? And if you are saying something, yeah,
it's good to see the amount of visual programming and also the basic knowledge of programming language. I hope the next example will appeal to that crowd.
Yes, I hope so too. And so let's jump right into the second example. But before that, I'd like to ask Rajana to tell us a bit something about Karamba idea, about its history, perhaps the vision behind it, and to kind of introduce the concept that of that example that Nathan will be showing in a minute.
Yeah, thank you, Wojtek. What is important to do is to look at the bigger picture of all the technology we see today and how we can use it to improve our projects. So traditionally, the design process of the global model and the details is separated. So at a later stage, the steel contractor will actually design it. And if the engineer up front didn't take into account the connections properly, you might end up with connections being governing for the cross sections. So at this late stage, when you want to increase a cross section to make the connection strong enough to transfer all the forces, you might end up with conflicts with other elements in the building. For example, ventilation ducts going underneath your beam, or there's a certain floor height that needs to stay the same above it. Otherwise, you get into a conflict with an architect. So the possibilities of changing that are quite limited. So you maybe have to resort to really expensive solutions, or maybe it's not buildable at all in the worst case. On the other hand, while designing a steel structure, you want to streamline both your connections and your global structure so that your both levels of detail are designed with the same philosophy. In other words, that your the connection design lines up with the assumptions you have made in your global structure. Is it hinge, is it moment resisting, or is it like flexible? This is of course extremely important to make the structure work as intended. So yeah, where does Karamba idea come in? So a great solve would be to fully integrate these two procedures. And with the use of computational tools and how powerful computers are nowadays, we actually can. And therefore, only one person will be responsible, or maybe a team at one company, for doing the whole design, like the structure and all the connections. And in my opinion, this is doable since connections are really repetitive. They have small deviations from one another, so they are one of the best things to automate. Similar all along, but small deviations. So we can actually do this with computational tools. And yeah, you may ask, where does Karamba fit in this? Karamba idea fit in the story? It actually started off with my graduation project, where I graduated in this topic, and I built a workflow with Grasshopper and C# components, which had methods of the API and could do this integral analysis. But after graduation, Bouwen Staal, the branch organization, offered me to continue with this subject because they saw this problem of the separation of these two tasks as something which was really present within the steel industry and was really resulting in sloppy design. And maybe this development could be one of the possible solutions to it. So one of the deliverables of this project was to give engineers a tool or a plugin that they can easily automate their own connection design, and therefore bring connection design more to the front of the design process. So I refactored the code of my graduation project, and I created Karamba IDEA. I named it that way to get an immediate audience, to get immediate users. In the first version, you were only able to export joints, so no design whatsoever, only export the naked joint, as Wojtek just named it. Afterwards, we developed it further. You would be able to code your own connections, but this was quite difficult and not for the general structural engineer. You were able to apply templates, but these templates were fixed, so not adjustable. So right now, with the help of Nathan, we are making like everything you can do within the user interface doable with Grasshopper components. That, in other words, you do not have to know how to program. You do everything with visual programming, and you basically do not have to open IDEA StatiCa even once, maybe only to check whether you are doing things correctly as desired. So we are going through that path, and I must say that Nathan has been extremely helpful in that way, especially since his experience with developing Geometry Gym. Yeah, the plugin is going really to the next level, and we're still in developing mode. Nevertheless, we already released the version, but you can see it actually has a beta phase. We want to make it more Grasshopper operatable. So if you use it and you have any questions, please do not hesitate to ask us. And right now, Nathan will show a typical workflow, which I am really excited about, and I think you will also be really excited about this new functionality.
All right, thanks a lot, Ryan, for this introduction. And you said it correctly. Let's hand it over to Nathan, see what he has to say and show regarding Grasshopper and visual programming workflows.
Thanks, Ryan, for that introduction, and thanks for letting me go through some of the amazing stuff that you've done with Karamba IDEA. So today I just want to go through a quick example, and I really just want to demonstrate some of the enhancements we've made to Karamba IDEA. And typically they are around the API calls that are available in IDEA connection now. So once you create your IDEA connection, how can I start to interact with that through the API and also in Grasshopper? So some of the things to start are, connection costs, obviously connection results, but also, modifying connection parameters as well, along with some enhanced template applications. So today I just want to go through a simple truss example, and if you haven't, if you're not familiar with Rhino and Grasshopper, Grasshopper is a visual programming tool or interface that allows you to create geometry and use its parameters to, I guess, modify it. So this particular example's got, a length that you can modify. I could also modify the divisions in the truss if I wanted to, the height of the truss. This example here, I've also allowed for the location of the kink, and I also wanted to demonstrate the ability to sort of locate truss splices as well on this truss. So where do I want these trusses, splices, or and how can I move them around? And you can see the connections being added as well. So I'm not going to go through the geometry creation in any great detail. This example will be available, so you can have a play once you you have it. So I guess once the geometry's been created, Karamba 3D, which is a plugin for Grasshopper, allows you to generate that structural analysis model, and also sort of do your real-time structural analysis within Grasshopper. And one thing that allows you to do is create groups of members. So if I've broken up my geometry creation correctly, I can start to assign these to groups. And in this example, I've spoken up the different groups in column, top chord, etc. And mainly, one of the other things I've done for this example is split the diagonals into a diagonal member and a splice member. So where the diagonal occurs at the splice location, that's going to be grouped as a different member, and that's going to tell the algorithm that categorizes the connection that that's a different connection type, and I might want that to be bolted rather than welded. So once the structural analysis model has been created, we can start to use Karamba IDEA to start to work with IDEA StatiCa. So if you've used or seen some of Ryan's examples in the past, he does a conversion for us using the create project component, and there hasn't been much change in the create project component. So that's still very similar. And what that's doing is taking that Karamba 3D model and converting it into basically an Karamba IDEA project, which we can start to use to create IDEA StatiCa connection files. Just before I get into the more advanced Grasshopper stuff, I want to show a component that we have added as a part of the recent enhancements, and that is the export to model BIM. And what this does is directly exports an IOM or model BIM file, which can be imported directly into Checkbot. So I've just opened Checkbot here, and under the import tab, I can import this IOM, and I can basically import my model BIM file. And what this is going to do is automatically create all the connections for us. So if you've done your structural optimization already and you just want to work on connections, or you want someone else to work on your connection design, you can do this and manage your IDEA connections, natively within IDEA Checkbot. So going back to Grasshopper, and one of the major changes that we've made to the plugin is to be able to now deconstruct this project. So instead of using or saving connection files at the project level, we can now start to work with joints in more of a tree type structure. So the deconstruct project component allows us to import that Karamba ID project and get a list of the joints available. It also can provide a list of all the brand names or connection categories that have been created based on this create project component. So this allows us to work with joints more flexibly. So I still want to use the brands that have been assigned to the joints in this instance, but what I want to be able to do is reconstruct the trees, because I want to work with them in more of I want to work with each of the category of joints. And so using some Grasshopper magic, I can then reassign all those joints into lists based on their brand. So you can see here I've got two joints of brand 0, and they're obviously my bases of my columns. And I've got 8 joints of my 1145, which is my top chord my top chord connection. For this example, I really just want to work with my top chord connection category. So I'm just going to take a tree branch now and select my connection category and put in my 1145. And this is mainly just to reduce the calculation time down the line. Now, what I also want to do is I kind of know this truss is it's just a one-way spanning truss, so I know that my that it's going to be reasonably symmetrical, and my joint 7 is probably going to be the most critical of this 1, 1, 4, 5, and joint 12 is probably going to be the least critical. So what I'm going to do here is I'm just going to take out all of those joints. I'm going to split them in half, and then I'm just going to take the joint 7 and joint 12. So those are the ones I want to work with in this for this example. So I've created a template for my top chord joint, and it's going to be reasonably similar, but what I've done with this one is created a couple of operations. You can see here I've got a stiffening plate that I've added, and obviously my post or chord and my diagonal. But what I've done in terms of parameters here is I've tried to create a template which can allow me to have, I guess, a maximum sort of connection type, and then maybe more of a minimum connection type. So maybe I only want to put this stiffening plate on where the loads are very high, or where the loads are low, I don't want this stiffening plate at all. So what I've done here is I've created basically a Boolean parameter, named it stiff plate, and what I want to do is if that is set to true, then I'm going to have my all the operations that relate to that stiffening plate as active, and if not, I'm going to have that stiffening plate removed. So I can change this to false, and then I can set this to model, and then you can see that basically my connection is going to change to just a welded type connection with these members just coming in. So maybe I want to be able to change those parameters to change how my connection might interact. I've also again allowed the changing of the post and diagonal weld sizes. So in order to assign that template which I've created, I've exported that as I did before, and I've just saved that in that folder. So I can use the import idea template component, and I can import that into Grasshopper, and I can also now start to deconstruct that template, so I can actually see what parameters are available in there. And what I might want to do is at the creation of that idea file, I might want to set how I want the parameters to be assigned. In this case, I'm just going to stick with what is available in the template, and all I need to do is do an assign the template to the connection, and you can see here that I could also provide parameter modifications that I want to apply if I wanted to. But in terms of this, I'm just going to use a modified joint component. I'm going to take the joint, and then I'm going to assign that template to it. I could change the name or a couple of other things that will be available in the future as well. So one of the other enhancements that we've made here is we've split apart the create idea file with the connection. So I can go ahead and bake those connections now, and you can see that running idea StatiCa pops up. So you can see that the connections have been baked, and I've got my idea connection C7 and C12, and the modified basically just means that there's been a template assigned. So it's similar to how it was before. So I can go into my working joints here. I can click on the brand, and then I've got the two joints in here. So you can see, similar to before, I have my IOM and my IOM results, and I've got my my connections as well. So I can click on this, and you should be able to see that I now have my template assigned and operations. Very good. So I'm just going to close that again. And now what I want to do is be able to calculate that component. So first, I'm not going to do any modifications to it, but I want to calculate that and see how the base template works, you know, for those two extremes of the connection. So those have been calculated, and you can now use a connection results component to basically get the results of each of those connections. And then you can also use a deconstruct item result. If you want, you can also, the result output does come out in JSON, so this is kind of how it's displayed as well. So in terms of the connections, you can see, I can see that the check status on these connections, the connection 7, I see that my welds are failing. And in here, I can sort of see where, you know, some of the welds on SP1 are not being checked correctly. If I look at the other connection, that seems to be going fine based on the plate, the stiffening plate being added to the connection. So what I'm going to do quickly is just show how now we can change some parameters within Grasshopper. So once that file has been created, what I can also do is deconstruct some of the information that's extracted from IDEA when that's baked. So one of the outputs here is the parameters, so I can actually see now in this connection that I've got these parameters that I can start to play around with. Obviously the stiffening plate and the chord weld and the diagonal weld. And I can modify these parameters without actually having to rebake that connection file from Grasshopper. So for instance, now I'm just going to see, all right, what if I update the connection welds for that extreme case connection, and I also want to see what happens if I remove the stiffening plate from the lower force connection. So I can update those welds for that. I'm going to keep the stiffening plate for connection 7. I'm going to remove the stiffening plate for the other ones, and I'll update the welds to 0.005. So I can set those parameter values. I can then go in here and modify those, use the modification, and what that's going to do is apply those modifications, and then it's going to rerun the calculation. So that calculation has now been rerun, and we can see that both connections are passing. So the connection 12 actually doesn't need that stiffening plate. So we can go in and go back into the joints, and I can open up connection 12, and I can open up connection 7, and we can just see that everything's been done correctly. So for connection 7, that you can see that the cut welds have been applied. And then if I go back to connection 12, you can actually see that the operations for the stiffening plates and cuts have been removed. And I can start to look around, and you can see that I've just got simply welded connections here. So that gives an introduction to some of the improvements that we've made in Grasshopper, and I'm very interested to see how you guys might take this and start to look at different ways to sort of use it to optimize structures and connection designs. So I'll pass back to Wojciech now, and thank you.
Okay, Nathan, thanks for that demonstration. Hopefully this has given you all an idea of what is possible, and certainly this is not the only thing that is possible using the API. We would love for you to be able to test it out. And since we are nearing the end of the webinar now, I'd like to ask you, if you found any of this interesting, perhaps even exciting, get involved with us on GitHub. You can post questions or requirements you might have about your workflows in the discussions. You can use the issues tab to report any bugs you might find. And finally, our wiki here should prove an invaluable resource to you if you are looking to learn more about this. If you are actually a developer looking to create a tool, perhaps need some more guidance after reading the wiki, don't hesitate to get in touch with us, any of us on LinkedIn, and see if we can help kickstart that idea of yours. We could now answer one or two, or perhaps three questions. Adam, if you have some from the audience.
Yes, hello to everyone. This is Adam, today's technician of the webinar, and I'm collecting and answering the questions on the way. And so let me pick three most interesting questions for now and ask them aloud to Wojciech and Nathan. So question number one, somebody is interested. Oh, I'll just read the question as it is. Can I use the Grasshopper workflow with other software such as SAP 2000, Start Pro, etc.?
Nathan, you want to take that?
Yeah, I can take it. You can use the Grasshopper plugin with other software. The Karamba IDEA create project component actually isn't fully reliant on Karamba 3D. So as long as you can do, as long as you're converting to converting the inputs correctly, you can sort of create a Karamba IDEA project. One of the things that we are looking at in the future is to make that a little bit easier, and also start to add the functionality to import different file formats such as SAF as well, directly in Grasshopper to create those projects. So
All right, thank you. So another question. Question number two. Standard Karamba is not needed. Only Karamba IDEA tool is needed. That's probably to be able to use the IOM as the questioner.
So I'll just quickly answer that, since the answer will be a bit similar to the first one. You actually need Karamba 3D in order to get your internal forces in your parametric design in Grasshopper. But other than that, the rest of it is quite independent. So once you have your model with your forces, no matter where they came from, be it Karamba 3D, SAP, or any other software, you can use Karamba IDEA plugin for free. And the download link will be there on the webinar landing page too.
Yes, maybe Wojciech, can you show our attendees where they can find the resources, the links
Sure.
to download the Karamba IDEA and other
Gladly.
resources?
So you just go to ideastatica.com, support and learning, webinars, and here you should find today's webinar. So I'll open this one, scroll down, and here are all the handouts, resources, whatever you might need. Download Karamba IDEA. So this will redirect me to Ryan's GitHub Karamba IDEA, and you can download the plugin from here.
Very well. That's great. Thank you for that. And the last one to be read aloud. A couple of questions regarding our concrete application. So let me just pick one. IOM model can generate also files for concrete module. Does IDEA StatiCa plugin, is it also developed for concrete calculations in applications like RCS, Beam, etc.?
Okay, so if you are looking to design concrete in an optimized way, then you can. IOM is also capable of generating those files. There will actually be a short survey at the end of the webinar. When you close down the panel, you will get a short survey, and you can select concrete from one of the options there, asking you what is the most interesting automatic workflow. So if you select concrete, we will know that you are looking for it, and we might perhaps even meet at another webinar doing something on concrete automation.
All right.
Very good.
Thank you very much for that. I think that's all for the questions. So
I think so. We've run out of time. Thank you, Adam. I'm just going to quickly mention there are some upcoming webinars you might want to see. If some people are interested in concrete, we have the Concrete Summer Series, July 12th, a beginner's webinar, and then Connection Wednesdays returns after the summer break. I already spoke about the survey, so please, if you fill that in, that will help us a lot when preparing other webinars and perhaps even a more in-depth webinar on automation. You will be able to find the recording at the support center and on our YouTube channel. I'll just ask Nathan for any final words he might have.
Yeah, thanks. I not really, but just hope people enjoyed the demonstrations, and yeah, we're really excited about these types of workflows, and really excited to help you guys achieve what you want to achieve. So that's all I'd probably have to say.
Yes, indeed. Thank you, Nathan. And thank you, Ryan, for joining as well. We are hoping for a continued and fruitful collaboration on these visual programming tools. So thank you once again, all for joining us today, and have a great rest of the day.